Hello everyone and welcome to all of you to our channel Schrodinger's Cat, and this is Devabrata here. So in your previous lecture we had discussed the work energy power from the class 12 from the class 11, and today we will discuss the electromagnetic induction and the alternating current. So I just confess one thing, that for your exam point of view we just here do the chapter summary in a nutshell and do the previous year problems coming in NEET, JEE Main and Advanced, and after we complete all the topics we just do theory elaborately. So let's get started. So basically we just cover here magnetic flux, Faraday's law and Lenz law, motional EMF and eddy current, mutual inductance, self inductance, and the alternating current, introduction to alternating current and voltage, AC circuit and power in AC circuit, resonance, transformer and AC generator, and the total number of questions coming in the sections that the NEET exam 2 or 3 questions, JEE Main 3 or 4, and the JEE Advanced 3 questions are coming in these topics. So this one is another important. So first of one, that for the electromagnetic induction, so basically we just draw here a line for your clarifying of 2 sections. So first of one, that the electromagnetic induction, that the magnetic flux is written as the phi equal to BA cos theta, and the Faraday's law of electromagnetic induction, that first law, whenever the magnetic flux linked through area bounded by closed conducting loops charges, an EMF is produced in the loop. This is the statement. And the second one be the induced EMF is written by, this is basically the Faraday's law, that the induced EMF epsilon is written as minus del phi del t. When del t tends to 0, it is written that minus d phi dt. This is the mathematics. And for n number of turns, that the epsilon would be minus del n phi by del t. And second one, the Lenz law, that the direction of induced current is such that it opposes the change that has induced it. So induced EMF, the Lenz law, that the induced EMF epsilon be the minus n del phi del t in volt, and the induced current in circuit, this is important, induced current in the circuit, that I is equal to epsilon by r is equal to n by r del phi del t in ampere, and the induced charge in the circuit, that q equal to I into del t is equal to, just put this value, n by r del phi del t into del t would become that the n by r into del phi. And this fourth one, be the motion of conductor in uniform magnetic field. So this is conductor, that the plus minus, and here this direction is V with velocity. This is magnetic field with an angle theta. So here, and this is the L. So here the induced EMF between end of the conductor be the V equal to V. This V is the induced EMF and this V is the velocity, VBL sin theta. So if theta is 0, then V equal to 0. And the second one be the mutual inductance, that let two coil of radius N1 and N2 with the turns N1 and N2. So basically this is a coil and that is another coil. This is radius R1 and the R2. R1 and the R2. This be the current I1. This is the N1 and this is the N2. So we just write for this the mutual inductance M is mu naught by 2 pi R2 square by R1 N1 N2, and epsilon in smaller loop when epsilon that M di dt. This is for the R2 much less than R1. So next one, that the self inductance of a circular coil. So that we know phi equal to BA. So put this value mu naught pi NIR divided by 2. So self inductance, the L would become that N phi divided by I, and the self inductance of the loop would be L equal to mu naught by 2 pi N square R. And self inductance of solenoid. Next one, self inductance of solenoid. This is a solenoid and the length L. This be the current I and this be the R. So here L would be mu naught mu R pi R square, mu naught mu R pi R square N square L, and the induced EMF here epsilon would be L di dt mod value. Next one, the energy stored in a inductor. The energy stored in a inductor, suppose this is a coil with resistance R. So this one is epsilon and here the key, this is L and the R. So here we just write the power supplied by battery, that the epsilon I is equal to rate of energy stored in inductor, that is we just write here L di dt into I. This is basically this is the epsilon I plus I square R. So here the energy stored, you would become half L I square. and the energy density U is basically the energy stored per unit volume. This is written as that the U by V would be V square by 2 mu naught. Next one, that just draw a line. Next one be the another important thing, that inductor in series and the parallel. Suppose this is an inductor, two are in series, so this is the current I and the outgoing. Here L1 L2 be the inductance, so equivalent Ls for series L1 plus L2, and for the parallel case, suppose this is this one, and here the current here I1 I2 total current I, and this is the L1 and the L2. For that case the L parallel would become 1 by L1 plus 1 by L2. Next one, that the induced electric field, that for the induced electric field the EMF would become epsilon closed line integral E dot dl. Basically this is time varying magnetic field. Here the direction, here the E electric field, and here the B magnetic field perpendicular with electric field E. So here E is the induced electric field. So next one, that the growth of current in LR circuit. So for the LR circuit, that this is a L with series in R with EMF epsilon, that is L and the R, and here the voltage difference is VL. So using Kirchhoff law we just get the induced EMF L di dt plus I into R. And here the current, very important, that the epsilon R 1 minus exponential minus t by tau, and the VL voltage difference between the inductor, that the L di dt, that would become the epsilon exponential minus t by tau, where the tau basically the L by R. This is the time constant. So next one, that, and one thing is that here the graph I versus t, and this graph is I versus t graph, that would linear increasing exponentially, and for the VL versus time decreasing exponentially, and this value become the epsilon and this value epsilon by R. So next one, the decay of circuit in LR circuit. So LR circuit decay, that this is basically the L, and here this is the R, RL, and this is the current I naught S. So by using the Kirchhoff law, that L di dt plus IR is equal to 0. So I would become I naught exponential minus T by tau, and the epsilon L, this voltage difference, the epsilon L would become that minus L di dt. Just differentiate and put this value, this would become the I naught R exponential minus T by tau, where tau is the L by R time constant, and this graph would be like that, the same type of graph. This graph is basically the reverse for, not same, the reverse graphs, like I versus T would become, and the V versus T would be same. Basically here the I versus T, the 0, and the here the epsilon L versus T, and where this point is basically the I naught, and here this point is the I naught R. And next one, that LS circuit, basically LC oscillation. For LC oscillation, that here is a capacitor C with L. This is C and the L plus Q minus Q. This is the S. So this energy constant. So basically energy capacitor plus energy inductor equal to constant. Basically the half Q square by C, basically Q square by 2C plus half L I square is equal to constant. So you just omega is 1 by root LC, and this is very important, the frequency 1 by 2 pi root over 1 by LC. This formula is very important. This is the frequency. The nu would become 1 by 2 pi root over 1 by LC. So go ahead, our next topic, that the alternating current, basically the AC. So we just draw a line for your better clarifying of my board. So next, that here that the I current is equal to I naught sin omega t, and the V, that V naught sin omega t for the AC, and the mean or average value of alternating current. The mean value, that Im, basically the 2 I naught divided by pi in the first half cycle, and the root mean square value IRMS, basically the I naught by root 2, and also the VRMS is equal to V naught by root 2. AC circuit containing only resistors. So next one, that AC circuit with only resistors are, that here the resistors and the AC given, this is the R, here V equal to V naught sin omega t. So in that case, the effective resistance Z would be V by I, that is the V naught by I naught that is basically capital R, and the power P equal to VI. So V naught I naught sine square theta, basically theta omega t, and the average power basically half V naught I naught. Just put the value V naught by root 2 and the I naught by root 2. Basically the average power P average, that become V RMS into I RMS. Next one, AC circuit containing only capacitor. Only capacitor. So here just capacitor and all the same, and put the AC, this one. So here I leads the EMF by 90 degree. The characteristics I versus V is in 90 degree. I leads EMF by 90 degree, and the reactance of the capacitor, that the XC reactance, is 1 by omega C, basically the 1 by 2 pi FC, 1 by 2 pi FC. CV the capacitor, and here the average power P average, that half V naught I naught sine 2 omega t. V naught I naught sine 2 omega t. Next one be the only inductor, that L. So this one. Here V lead current, that V I, that is in 90 degree. So here impedance, the impedance XL is equal to omega L is equal to 2 pi FL, 2 pi FL, and here the average power, that P average equal to VI, just put this value half V naught I naught sine 2 omega t. Next one be the LR circuit. So we just cover only resistor, capacitor and the inductor, and now we just go through the next one, that the LR circuit. Basically this is the L with R. Here the V equal to V naught sine omega t. So for the LR circuit, that this is the component, this is V, and here this is the VR, this is phi, this is VL, and here is the I. So here the impedance Z is equal to root over of R square plus XL square. Just put this value, so impedance would become R square plus omega L square, and the tan phi, these are the very important, tan phi, that the VL by VR. So VL means IXL, so it would become XL by R. XL means the omega L, omega L by R. So omega L means 2 pi FL 2 pi FL by R, and the P average, that is the VRMS IRMS into cos phi. Next one, that the CR circuit. So this is the C with R, that is CR. So this is the VC and this is the VR across here. So this one, that one, these are the V. So this is the phi VR and this is the VC. So here the impedance Z, same one, that R square plus XC square, that would become root over R square plus, this is the 1 by omega C, so 1 by omega C whole square, and the here tan phi, the angle between this one, that would become the 1 by omega CR. So this is basically the 1 by 2 pi F CR. So next one, that the LC circuit. For the LC circuit, that the LC, this is the L with C, LC. So here the impedance Z is XL difference XC, basically the omega L, this is the difference by 1 by omega C. So here if C case, so this is the I and this is VL and this is VC. So here this is the V is equal to VL minus VC, and this is the 90 degree. So if XC greater than XL, so I lead V by 90 degree. Next one, that XC less than XL, that I lags V by 90, and XC is equal to XL, that impedance Z would become 0. This is the 3 condition, and this condition would become the resonance, that XL equal to XC, where the omega L equal to 1 by omega C, basically 2 pi FL is equal to 1 by 2 pi FC, that the F square is 1 by 4 pi square LC. So F would become 1 by 2 pi 1 by root LC, basically the 1 by 2 pi root over LC. This is the resonant frequency. Resonant frequency. This is the resonant frequency equation. So next one, that the LCR, that the L, C and the R with AC apply here. LCR, this is the V equal to V naught sin omega t. So here the phase diagram, this is the I and the VL, this is the VC, and here this is the VL minus VC, this is the V, and this angle is phi. So here the impedance, that Z equal to root over of R square plus omega L minus 1 by omega C whole square, and the tan phi, the angle, that the omega L minus 1 by omega C divided by R. So the phase would become tan inverse omega L minus 1 by omega C divided by R. And another thing is the power factor. This is another important term. So for right angle triangle, that is R with an angle phi, this is the omega L and this is the R square plus omega L square. So for LR circuit, we just know the tan phi is equal to omega L by R, and the power factor is written as the power factor, that the cos phi is equal to R by root over R square plus omega L whole square, basically the R by Z. So power factor is equal to R by Z. So we just conclude here that our electromagnetic induction and the alternating current. So go ahead our problem discussion session. So first one is coming NEET 2016, saying that a uniform magnetic field is restricted in a region of radius r. The magnetic field changes at the rate dB/dt. So I just suggest you just pause the video and go through all the questions with reading and conceptual with understanding. So loop 1 with radius r greater than smaller, and loop 2 r is outside. You have to find the generated EMF generate, you have to find. So you just know the equation, that the induced EMF, this is the d phi dt, that phi equal to BA, that is the pi r square B, and the d phi dt here, thus do derivative pi r square dB dt. So the E1 would minus the d phi 1 dt, just put this value pi r square dB dt, and for the E2 minus d phi 2 dt. So here would be 0, basically the phi 2 is equal to 0, that for the this one the phi 2 would 0. So I think minus dB dt pi r square in loop 1 and 0 in loop 2. Basically here is no cavity, phi 2 here 0, so here phi 2 is equal to 0, so induced EMF would be 0. D would be our correct answer. Go ahead our next one, that NEET 2024 recent type of questions, saying that a 10 microfarad capacitor connected to a 210 volt 50 hertz source. You have to find the peak current. You have to find the peak current. The IP is equal to what? So this is a circuit where we have to find this is a C type circuit, C only. So you have to find the XC. This is the 1 by omega C. So 1 by 2 pi FC. Just put this value 2 pi 3.14 F frequency 50 Hz, and the C 10 microfarad, so 10 into 10 to the power minus 6 farad. So this would become 10 to the power 3 divided by 3.14. And the peak current formula, that the V root 2 by XC. For C only circuit, the peak current would be V root 2 by XC. Just put this value V210 root 2, and the XC we just find 10 to the power 3 by 3.14. So this would be 0.93 ampere. B would be our correct answers. Go through next one, that JEE Advanced 2017, the instantaneous voltages at three terminals marked XYZ are given Vx, Vy and Vz in the equations. An ideal voltmeter is configured to read RMS value of the potential difference between its terminal. It is connected between X, Y and then YZ. First one is XY and then the YZ. You have to find the readings. Readings means the voltage of RMS value and voltage RMS value and the terminals, and this is the MSQ type questions in JEE Advanced MSQ. So one or more than one answer should be the correct. So I just draw a figure here, that here this is the V, so this is the V naught, and this is the 30, and whole one is the 60, and this is the root 3 V naught. So by this figure, that the Vxy, that potential difference Vx minus Vy, so put this value V naught sine omega t 2 pi by 3 given minus V naught sine omega t, V naught sine omega t plus 2 pi by 3 plus just phase change here sine omega t plus 5 pi. Just get the angle phi, that the pi minus 2 pi by 3. So this would become the pi by 3. So now the Vxy, that this resultant root 3 V naught sine, this is the 30 degree, so omega t plus phi means 30 degree. So Vxy, this is the RMS, would become that the root 3 V naught divided by root 2. Root 3, basically the V naught root 3 by 2, and independent of choice of the two terminal. This two terminal is independent. So basically the independent of choice of the two terminals. So I think B would be a correct answer. We just get Vxy RMS equal to V naught root 3 by 2, and C would be correct because the independent of choice of two terminal means this terminal Vx and the Vy, this is basically the independent to each other. So independent of the choice of the two terminals. Next one, this is coming in the JEE Main 2023. A metallic rod of length L is rotated with an angular speed of omega, normal to a uniform magnetic field B. You have to find the induced EMF. So you just know that induced EMF is d phi dt. So d phi dt means B dA dt. So here B A, T means the revolution T. So B A means pi L square, T means 2 pi by omega. Basically the rotating, for rotating T 2 pi by omega. So this would become the half BL square omega. Half BL square omega. A would be a correct answer. Half BL square omega. This was the JEE Main type. Next one is the NEET 2022. That's saying a series LCR circuit with given inductance 10 Henry, capacitance 10 microfarad and the resistance 50 ohm is connected to a AC source of voltage V equal to V naught sin omega t. You have to find the resonant frequency. We just do here the resonant frequency, that so here given that V equal to 200 sin 100 t. This is basically the V naught sin omega t. This is the omega 100 and the omega means 2 pi nu. So nu would become 100 by 2 pi, that the 50 by 2, 50 by pi hertz. This is the omega, and the resonant frequency, that the nu naught we just discussed in previous, that the 1 by 2 pi root LC. Just put this value. This formula is very important for your short type questions, that the LC, thus L means 10 and the C 10 to the power minus 5. Put this value, so it would become that 50 by pi hertz. So nu equal to nu naught. Here nu equal to this, so nu equal to nu naught equal to 50 by pi hertz. So I think A would be our correct answer. Nu equal to nu naught 50 by pi hertz. So we just now complete 5 important questions from NEET, JEE Main and Advanced, and I think after solving these 5 questions of a conceptual, and you try to solve all of the questions coming in NEET, JEE Main and Advanced. So I usually give you 5 another same type of questions for your better concept and understanding. You just pause this video and take a screenshot. I just wait for the 8 or 9 seconds. So I think you've taken the screenshot of this problem. So basically we now just cover 10 important questions and chapter summary in a nutshell of the electromagnetic induction and the alternating current. So last one, that the contact part. Solve this homework, and if anyone needs the study material of my YouTube lecture, just mail without no hesitation with the cat syringes 1935@gmail.com. So last but not the least, that the thank you everyone, and stay well and happy. Have a good day.